Hey guys, welcome back. In this lecture, we will discuss uh, two examples one by one because it will take time. The first one is coffee bottling unit and the second one is fire detection system. In the coffee bottling unit, we would have like water, sugar, coffee, and then milk, heat exchanger, boiler plant, bottling, and circulating plant. So, as a lot of things are including, I'm assuming it is an interesting example. So, in this lecture, basically, we would discuss about the process and then we will discuss about its logic, like how its logic should be. You can also draw it and compare it with the logic Akram has made. Akram is one of my students. So these examples they will be demonstrated to you from Akram. Akram will take the lead and he will tell you, he will like first discuss with you about the process of these both examples, fire detection system and coffee bottling machine, and then he will share his logic which he has programmed with you, and he will like guide you or teach you like why he has developed the logic like that, and like what's the purpose and how it should be and how it should not be. So Akram will take the lead from here, so I hope you will enjoy it.
Hi guys, this is Akram Shahid. I shall explain you the two examples as mentioned by Sir Raza Khalid. First one is the coffee bottling unit and second is the fire detection system. In this video, we will talk about the coffee bottling unit and in the next one we shall discuss the fire detection system. So let's start. Firstly, we see the block diagram and the process. Here we have the water container. These two bottles, one is carrying the coffee and other one is carrying the sugar. This container is carrying the milk. Here LS1 is the lower limit sensor of water container, while the LS2 is for the coffee, LS3 for the sugar, and also LS4 for the milk. Here we have four valves, V1 for the water, V2 for the coffee, V3 for sugar, and V4 for the milk. Here we have the mixer and a heat exchanger to boil the water. Here the valve V5 is to fill the bottles. Okay, and the CP1 is the circulating pump to boil the water. So see the process. On pressing the start button, valve V1 will be open to fill the water in the mixer. Valve will be open till the LS1, the lower limit sensor of the water container, is detected. Now after filling the water in the container, we shall operate the circulating pump for 30 seconds. The process is mentioned here, and after 30 seconds we shall open the valves V2, V3 and V4 to provide coffee, sugar and milk in the container. After the lower limit sensors LS2, LS3 and LS4 are detected, we shall operate the mixer. Mixer will operate for 30 seconds, and then we shall open the valve V5 to fill the bottles until the lower limit sensor LS5 of the container is detected. Now let's move to the TIA portal. Now I shall explain you how the things are working. So let's see. Here we have the start and the stop button. I have memory initialize to start the process. Here as we press the start button, this memory is latched, and when we press the stop button, the memory is unlatched and the process stops. Here after initializing the process, valve V1 will be opened, and it will remain open until the lower limit sensor of the water container LS1 is detected. After that, the circulating pump CP1 will operate for 30 seconds, and then the valves for the coffee, sugar and the milk V2, V3 and V4 will be opened simultaneously. When the lower limit sensors for the coffee, sugar and the milk will be detected, LS2, LS3 and LS4 will be detected. These valves will turn off. After that the mixer will turn on. For here I have taken the mixing time for testing 5 seconds. Otherwise in the process we have 30 seconds. I've just taken it 5 seconds for the testing purposes. When the mixing is done, after that the valve V5 will be open to fill the bottles until the lower limit sensor of the container LS5 is detected. So in this way the process will flow automatically and repeat until the stop button N is pressed. So now let's download the logic into the PLC and test it. Now let's go online and test the logic. Here I have took the start button and stop as memories for the testing purposes. Otherwise these are the real-time inputs of our system. So let's press the start button by Control F2 and then close it by Control F3 as it is a push button. So the initialized memory has latched and the valve V1 is opened to fill the water in the container. Now when the lower limit sensor LS1 for the water container is detected, the V1 valve will be stopped and the CP circulating pump has turned on. It will keep on for 30 seconds and after that the valves V2, V3 and V4 will be turned on to pour the coffee, sugar and milk in the container. So let's see. Now after the 30 seconds circulating pump has turned off and the valves V3, V4 and V2 are turned on. So when the coffee is poured into the container and the lower limit sensor of the coffee bottle is detected, means LS2 is detected, the V2 valve will be turned off, and when LS3 is detected, V3 valve will be turned off, and finally when the LS4 will be detected, V4 will also be closed and we have seen that the mixer has turned on. It will keep on for 30 seconds and after that the valve V5 will be on to pour the coffee into the bottles. So let's see that after the 30 seconds mixer has turned off and the valve V5 has turned on to fill the coffee into the bottles until lower limit sensor LS5 of the container is detected. Now let's turn on the lower limit sensor of the container. Here we can see the valve V5 has turned off and the process will repeat in the same manner. Now let's see that the V1 valve for the water has turned on again. In this way the process will keep on repeating until we press the stop button. Now let's press the stop button and end the process. Control F2, the stop button is pressed and the valve V1 is closed. So in this way we made a logic for the process and it's working fine. So that's all for this video. In next video we shall discuss about the fire detection system. So see you in the next video.